Evening, everyone. Our goal today is going to be to finish section 15.6. I reduced the section by a couple of questions, just so that you'd have enough time to get them finished, and hopefully have some time after that once you've done the test to get ready for your midterm. What I'm intending to do is once we finish today, on Friday, I'm just going to have a drop-in section starting at the same time, 5 o'clock. So hopefully by Friday you'll have had some ideas of what you need help on, and we can go over it. And it's a drop-in section, so I don't expect you to hang about unless you want to hang about. You might just turn up to find out how to do 2 things and then leave and go back to your studying, and that's fine. If you want to watch it the whole time, that's fine. The only thing I would ask you to do, if it's not a problem, is that with a little bit of editing at least, that you'll let me put it online as another resource for people who can't make it, because the chances are that if you had some issues with whatever it might be, the second derivative test or whatever, right, that you might want other people to benefit from that. So the questions that are left in 15.6 are pretty much a continuation of what we did at the end of Monday. We're going to do some triple integrals, and you can see some of them here. We're going to do some questions involving find the volume of a solid, which involves getting a triple integral. And we're also going to find the mass and the center of mass of a 3D object. And that's these 2 guys. So I'm going to jump right in to the first question. Here is the triple integral. And we're told something like the region E, this 3-dimensional region E, lies below this plane and above this triangular region. So one of the things you have to do when you're doing the triple integral is you have to find out what the limits of integration of x, y, and z are, right? So there's probably another sentence here. I think it's also confined, this shape here is confined within the planes. So if I start off by saying, okay, what do I know for sure? Well, I know that I've got z equals x. I also know I have a z equals 0. So that's pretty much told me the limits of integration of z. And if you imagine this triangle on the floor, right? So I've got an x-axis here and I've got y-axis here. 0, 0, 0. Since the last number is 0, it's telling me it's on the xy plane. I mean, they could have done away with those and just said, here are the 3 points that make up the rest of the region. And so I'm going to go for that. So that's the origin. That's pi comma 0. And that's 0 comma pi. And this guy is the piece of the solid that's on the ground, on the xy plane, right? It's built from this triangle, right? So we join them together on the floor. I'm going to go vertical on it. And if I go vertical, then the x is going to go from 0 to pi. So that's me got the limits of integration for x. And if I then do the last guy, y equals 0, and this guy, well, the top of the rectangle is the equation of this sloping line. So here we go. If you take that point to that point and you do a rise over a run, you find out that its slope is -1, so -1x. It has a y-intercept of pi, so there you go. And I'm just going to call it pi take away x because it looks pretty. So first piece of information gave me the limits of integration of z, which is this piece up here and the fact that it's on the plane. And these 3 guys, right, are all on the floor. So that's another reason why I know z is 0. And these guys make this triangle on the floor, and I use that to get the x and the y. So you put this together, your limits of integration are going to be from x equals 0 to x equals pi. Then I'm going to do y equals 0 to y equals pi, take away x. And then I'm going to do z equals 0 to z equals x, which is that guy. And the function was 3 times the sine of y. And the order I'm doing it is z's, followed by y, followed by x's. Are we good with the way that was set up? How I got the limits of integration for the x, y, and z variables? Right. Now, we have a lot of questions to get through today. So I guess the thing I'm going to ask you probably in every question is that enough, or do you want me to do the rest of the process just to show you how it finishes? Because if you say, yeah, I could do the rest myself, then I'm wasting your time by just, doing it anyway. But it's really up to you. You tell me. Do you want me to continue this or call this one good? And it's
Yeah,
okay
I'm good
if you
with this. I'm good with the setup only, but I guess I'm still a little confused about how you got the X and Y.
Look, these two?
Yeah.
Okay. Up here, they told me that it was a triangle, right? Now, if you plot these points, what I'm saying is that the Z coordinate is 0. So they don't matter, because that's just telling me the triangle's on the floor. And so here are the X and Y coordinates, and that gave me 0, 0. There's the pi 0, and there's the 0 pi. So I know that this triangle corresponds to this triangle here.
Mm-hmm.
Right. Now, if you want to describe the X and Y limits of integration that describes this shape, I've decided to go vertical. So that means X goes from 0 and it scans along to pi, so which is what that is. And then what do the Y's do? The Y's go, because you draw a little vertical, in this case, rectangle. The Y goes from the bottom, which is a Y value of 0, and it goes to the line. And what I did is I found the equation of that line by realizing what its slope was, -1, and that it crossed the y-axis at pi, so I got this guy. So I know that the y is 0 on the small side, up to the equation of the line in the top side. So that guy has a y of 0, and that guy up there has a y equal to this fella. And that was the limits of y's. There's the limits of x's. We already did the z's, because they told me z was x, and this told me z was 0.
Okay, thank you.
Okay, so if we can move on, and don't feel that just because one person says it's okay, that it isn't okay if it's not for you. So you can also say, okay, can we really do that, please? And I will do it. Right, question 8 is this one. We're going to find this triple integral, and they tell us that z is equal to 1 plus x plus y, and that y is equal to all this. And I probably missed out some extra bits. Yeah, it's bounded by the plane xy. So when you tell me it's bounded by the plane xy, what you're saying is that the floor is also a restriction, and that just means z equals 0. So if one of your restrictions on your solid is bounded but on the floor, that means z is 0. And then it goes to this. So it's a bit like a straight line coming down to the floor. So that's what my solid is going to look like. So I already got a freebie here. Okay. The equation of the plane and that the floor counts as part of the answer. That's essentially the xy plane, z0, and this is the other guy. So what do I have to work with now? I have to work with this information. Right. So what's the shape going to look like on the ground? Well, you tell me y equals the square root of x. Looks like that. You tell me x equals 1. Looks like that. You tell me y equals 0, which is just another way of saying the x-axis. You put those three things together, these three things here, that's the xy shape. So this time it's a kind of curved looking thing. I'm going to go vertical because I tend to go vertical rectangles, which means I'm scanning from left to right on the x's because I find them easiest to do. So in this case, the x will go from 0 to 1. Already got the z's. Now what's the y's going to do? The y's are this rectangle. The y value here, right, here is 0. And up here, it's the curve. Now I've got the restrictions for my y. Oh, got somebody in the chat. Let's see. Okay, gotcha. So, treble integral has to be set up. The guy that goes here is going to be 2xy. When we look at the three limits of integration, we have to decide who's first, who's second, and who's last. Right? You must have numbers on the end. So I didn't have a choice here. Check. Now, I do have a choice, but only one of the choices works. Do I do the y's in the middle, which is these restrictions, or do I do the z's in the middle, which is this restriction? And kind of yesterday, I think it was John that did it. You came up with a good way of saying it, and it was something like the ugliest one goes here, right? Or the most complicated one. Does that make sense? That the most complicated one is this restriction. So you would put in here, z equals 0 to z equals 1 plus x add y. And in the middle then, y goes from 0 to the square root of x. And now it's going to be a dz, a dy, and finishing with a dx. If you get these limits of integration in the wrong place, when you do the math, when you do the integration, you will find that your final answer has letters in it, variables in it. And that's a sign that you did it in the wrong order. But essentially, more complicated, less complicated, and always finish with a number. That's the rule for the order that you should do them in, right? Most complicated, less complicated, finish with numbers. Same question again, because these questions will change. Your answer at least will change. Is that good enough, or do you want to actually see the rest of this process? I'll take thumbs up, hands, sad faces, whatever.
I think I'm good.
We've got one good. Any not so goods?
I'm good.
Okay. Majority rules. Should put a number on that, shouldn't I? That was question 8. Okay. This one, and they're getting progressively uglier, is the region E is described like this. I guess I'm just writing everything again. Now, when I look at this, I already know a start and finish for the Y, right? So I guess that was a freebie. If you put these two together, put a big circle in, that's the guy we want, right? If you look at that, we do have the limits of Z. It's right now, I might change my mind, but right now I'm going to put that on this side and that on that side. Now I'm making the assumption here that this thing is bigger numerically than that one. Now I won't really know that answer until maybe later on when we'll be able to figure out whether it is or not, but there's only two choices. It's either that way around or I switch places. It's not that the limit of integrations are going to change, it's just who goes first and who goes last. So now you're kind of looking at, I got the Y's, I got the Z's. Where are the X's? Well, there's definitely no indication of X's here. And there are some X's here, but they're tied up with these two guys, right? You've got this guy here and this guy here. So what I'm going to have to do here is make this thing equal to that thing, and it'll tell me how those two curves, shapes, whatever they are, interact with each other. And so x squared take away 1, if I make it the same as 1 take away x squared, right, so set them equal to each other, I then get that, which then becomes that, which then says, oh, there is my limits of integration. X is somewhere between 1 and -1. So that's cool. Now I'm going to go back here and decide, based on the fact that X is somewhere between 0 and 1, does this order make sense? So I'm just going to pick a number that I know that's in this range. I'm going to pick X equals 0. When I plug X equals 0 in here, this becomes -1 and this becomes +1. Do you see I got it the wrong way around? So I know the limits of integration are okay. All I need to do is fix who goes first and who goes second. So got that again. Pick any number you like. I picked 0. If you feel like it, pick 0.98. It won't matter. Put 0.98 in here, put 0.9 in here. You'll find this is bigger than that. That means they were in the wrong order. If you had left them in the order that I've written up here, your answer would be numerically correct. It would be the same number. It just would be a minus instead of a plus, or a plus instead of a minus. In fact, in this particular, the correct order, the answer does end up being -64/3. And by the way, for triple integrals, just general triple integrals, the answer can be 0, positive, or negative, right? They can be any one of the three. So continuing with that then, now that I've got all the guys I need, it's going to be x equals -1 to x equals 1, y equals 0 to y equals 4, and z equals, use these guys because these are the right ones, x squared -1 to z equals 1 minus x squared. And the function we're going to do it to is just x take away y, and z, then y, then x. Now, I don't think there's any argument that z is definitely the ugly one, so that should be first. Agreed? Since this is a number, and since that is a number, could you imagine that you could switch these two and it wouldn't matter, right? But x, y, z seems to be a nice order. How are we doing with that one?
Can you take it, just do the X's?
Sure. What, just do the z's, this one here? I think that's what you meant, John.
That's what I meant. Plug in the equations.
Let's do it. The first two are just placeholders, right? That's those two. If you integrate this with respect to z, all you get is x take away y z. It's a bit like 5 gets you 5z, because neither of the rows do have a z in it, so it's just a constant. You'll then evaluate it at z equals x squared take away 1, and at z equals 1 minus x squared. And then you can do your dy dx after that. If you plug z for this guy, you get x take away y, 1 minus x squared, take away x minus y times x squared minus 1. So I plug z in here to get this, and I plug z in here to get that guy. This guy, take away that guy. And then I would basically FOIL the whole thing out and see what we get. I'm going to get an x, take away an x cubed, minus a y, plus a yx squared. That's the first lot. This one I'm going to get an x cubed, take away an x, take away a yx squared with an add y. See what that ends up looking like. So I'm going to have an x squared, take away a negative x, so that's 2x. I'm going to have a negative x cubed, take away an x cubed, so that's going to be negative 2x cubes. I'm going to have a negative y, take away a y, so that's going to be negative 2y. And I have this guy, take away a negative, I'm going to add it, so I'm going to end up with that guy. Now I can do my dy and finally my dx. Right. And it's just going to grow, isn't it? It's going to be an even uglier polynomial, you know, integration after this because of the parts. But at least you're plugging numbers in, right? In the same way the other one. And like I said a few minutes ago, because these are both numbers, couldn't I do the x's first and then the y second, and it would be the exact same answer, right? There's no issues with that's the only order. It's only when there's variables attached that the order becomes really important. If everybody's a number, you can do them in any order you like, and you're still going to be fine. Although some orders tend to be less work. That's a different question. Are we good? Let's move on. Oh, by the way, that answer, is that the one? Yeah, that one ends up being negative 64/3, which is fine. Now, I believe the next question, let's get my notes set up for it. Here we go. Is this one. Yeah, so this is the last version of a triple integral, right? Just a triple integral for whatever reason. So E is bounded by this cylinder. And a whole load of other stuff. And it's in the first octave, right? So there's a lot of stuff going on here. If you take this guy here and you rearrange him, you get that. And if you take the square root of both sides, you get that. Technically, you could get a plus or a minus square root, but because z equals 0, and also because it's in the first quadrant, do you see that has to be positive, right? So I now have my limits of integration for z. Cool. Now, if I focus kind of on these two guys, and typically when you get to the xy's, you want to draw a little picture, right? Just an xy guy. I've got the line y equals 3x. That's good. Now, since the question is in the first quadrant, isn't my picture just that guy, right? Nothing over here, nothing down here, right? It has to be pluses and pluses because everything's in the first octant, and that means everybody is positive. Now, what else do I know? I know that x equals 0. And x equals 0, I'll put it in red, is this guy. And then it looks like that we're stuck because I've got that guy, I've got that guy, but I don't have any stop there. Right, do I stop at y is 2? Do I stop at y is 4? I certainly can't go on forever. And that's when this guy, or this one, it's the same one, comes into its own. This thing is on the floor, right? This is XY plane. This thing on the floor means Z is 0. And if Z is 0, y squared will have to be 9. And if y squared has to be 9, technically y has to be plus or minus 3. But because we're in the first octant, y equals 3. So do you see what was hidden in there? Was that 3? So if you're trying to find out what the shape looks like when it hits the floor, make z equals 0 and see what pops out. Sometimes numbers pop out, but I've seen them when you put in z equals 0, a circle pops out. So that tells you on the xy plane there's a circle there, right? Maybe a triangle. Well, there is a triangle here. Now, this triangle will allow us to get the limits of integration for x and for y. And I'm just going to go with the flow, which means I'm still going to go with vertical rectangles. Well, I know x starts at 0. I need to know what that x value there is. But if this is 3, would you agree it's pretty easy to find out x was 1? So I now have the limits of integration for x. So we're left with just y. Now, this rectangle is not starting on the x-axis. If it did, it would be y equals 0 to something. It starts on that straight line. And that's the lower of the two, right? The top's this guy, the bottom of the rectangle is this guy. So I know that the big guy is 3, and the little guy is a straight line, which is 3x. There is my 3 limits of integration. How does that look? Are we good? This equation generated that, the z's. This piece gave me the line. This piece gave me the vertical bit. And then go back to this, making z 0, allowed us to figure out what the y would need to be, which gave us the last piece of the triangle. And once you got that guy, you can get these two. So our limits of integration then is those 3. The function is 2z. Okay. The first one, the one my finger is pointing at, this one here, x, y, or z. What should I use here? Any takers? Should this be the limits of integration z, the limits of integration of x or y?
Z.
Agree. Would you agree it's the ugliest looking one? So I'm going to do z equals 0 to that fella. Would you agree that the next ugliest is a y? So 3x to 3. And the x's go from 0 to 1. And the x's had to go there because they're the only one that had numbers on them, right? And they have to go last because of that. And this is going to be our dz, our dy, our dx. Okay. I'm not going to ask you, I'm going to do the next line. Let's do the next line of integration. So I'm going to do this piece first. So it's going to be 0 to 1, 3x to 3. If you integrate 2z with respect to z, you will get z squared. You will evaluate it from z equals 0 to z equals the square root of 9 minus y squared, and then you can do the other two guys when you're finished. Well, if you put a square root in here and square it, all you will get is 9 minus y squared, take away 0, which is that guy. Do you see it came out quite nice? And then do the next guy, and you're finished. Do you want me to continue this one, or is the back broken? Right, we know how this is going to end up. We're good. Kathy nods, I'll use it. I think one of the things you've maybe noticed, at least a couple of these questions, that the major ugly equation sometimes gets used to tell you two different things. Its initial use was to tell me this. Its secondary use was by making it 0, it allowed us to get these guys, right? And when you're doing a limit of integration, you need two guys, right? Start here, finish there, right? So you kind of need two things. And if you've only got one, the good chance that plugging in the Z is going to get you the other. Now we're changing tack for, I think it's, yeah, the next two questions. Question 11 and question 12 are asking us to find the volume of something. And that can be done by finding the triple integral, and I don't know why they changed the letters, it doesn't matter. The triple integral over some region R, right, of 1 dV. So if you ever get a volume, that guy is 1. So what's this region? This region is a tetrahedron enclosed by the coordinate planes and this plane. Right. We did one, I think this was almost the last question we did on Monday, so it's a very similar question, right? And I'm going to try and draw my best attempt at what this tetrahedron that they're talking about is. The first is, if it's enclosed by the coordinates plane, do you know that's just a fancy way of saying it's in the first octant? Right, the XY plane, the floor, and the side, you stick them all together, haven't you kind of hammered the thing into a quarter, right? In this case, it's in the first octant at least. So if you take this equation, which is essentially a plane, and you want to know where it crosses the z-axis, make these two 0, and you find out it crosses at 4. If you want to know where it crosses the y-axis, make z and x 0, and it finishes, or it crosses at 4. And then you want to do the x-axis, make these two 0s, and you end up with 2. So the tetrahedron that they're talking about, right, is that guy, right, that funny little pyramid shape. So I need to set up the limits of integration. The first one is start with this equation and rearrange it so you've got a z. That's one of my limits of integration, right? Z equals this guy. The other limit of integration is basically just 0. And it's 0 because doesn't this shape end up on the floor? And on the floor, Z is 0. No matter where on the floor you are, if you're on the XY plane, Z will be 0. So I've got my first limit of integration. So what I'm going to do now is figure out what the limits of integration for X and Y is. And to do that, I basically need to know, what does the floor look like? Well, if I redraw the floor, what we've essentially got is this little triangle here. And I know that the X is at 2 and that the Y is at 4, and the triangle looks like this, right? Just different orientation, right? So that's 0. And then I'm going to go vertical, which means that X is going to be 0, scan to the end, 2. And Y is going to, well, we've done enough triangles to know how this is going to end. In this case, isn't it in the bottom? So I get a 0. And isn't the top going to be the equation of that straight line with X's in it? And just looking at that picture, what's the slope of that straight line going this way? Somebody said something, I can't hear them, so they must have done.
-1/2.
Rise over run, you want to change it?
Oh, 2, -2.
2, -2. So -2x and crosses the y-intercept at 4. So there is all three guys. So if you want to find the volume of that tetrahedron shape, you're going to do x equals 0 to x equals 2, y is going to be 0 to negative 2x add 4, and z is going to go from 0 to 4, take away 2x, take away y, and the guy you're going to use is 1, a dz, a dy, a dx. Are you all comfortable about why z is here, why the y is here, and why the x's are where they are? Are you comfortable about ugly, less ugly, finish with the numbers? Okay. Back to my usual question. Do you want me to continue with this one? Or is this one good to go? Any preference? Continue or good to go? I'm not sure what that means, yes or no.
I was trying to catch up on note writing.
Oh, okay. Well, I'll give you a moment to do that. I'll just, while you're doing that, I'll tell you a joke. That gives you a chance to do two things at once, right? Okay. I may have told you this one, but who knows? What do you call a wolf that sees everything? No idea?
I don't know.
You call it a werewolf. Aware. Where? Aware. Well,
Aware. Okay.
oh god, that one died.
I get it now.
Okay, you got it. Are we good to continue then? I'm going to assume it is. I'll do the negative of not doing it unless someone says, hey, can we do it? So I'm finishing there. Oh,
I
by
gotta
the way,
know, where do you get your jokes?
I get that joke. I get that from students. Almost all my jokes come from students, and the really bad ones I remember. And so I don't think I've had any jokes of any of you. Teresa, do you have a joke? Because I just told you one.
I only have one. And
Is it going to be suitable?
yeah, it's pretty dumb.
Oh, I like dumb. Go for it.
It's just what happened to the peanut on the subway.
I don't know what happened to the peanut on the subway.
He was assaulted.
Oh, bad. Oh, bad. I like it. Did you hear about the two high school students who get caught at night in the car park of the school by the police? And one of them was drinking battery acid and the other was snorting gunpowder. Do you know what happened to them?
No.
One of them was charged and the other was let off.
I've never heard that one before.
Bad. John, you're scratching your head. That one must have been bad.
Nah,
No comment.
I have to give you credit for your delivery.
Okay. Not for the content, only delivery. I'll take it. Okay. Since that, by the way, that answer I just gave, if you want to do it as practice, is 16 thirds. And all the ones in blocks are what the answer would be if you went to the end. So if you do go to the end, you can check you've got it right. So the final one involving finding a volume of a solid is this story here. I'll look at it because these are quite cryptic because I don't write everything the question does. So let me look at the question, see what it says in full. It says use a triple integral to find the volume of the given solid. That's pretty close to it. And then they tell you that it's a cylinder y equals x squared, which is basically what that looks like, I guess. The plane z equals 0, and then y plus z equals 1. So we're given bits and pieces, and somehow or other, we need to get the limits of the x, the limits of the y, and the limits of z. What my brain is saying is two things that have Z's in them, which is almost always the direction I try and go. I try and find out what the Z's are doing. Now, if you rearrange this, isn't that the same as Z is 1 minus Y? So far, so good, right? So my limit of integration for the Z's is going to be from 0 to 1 minus Y. Are we good? Now, this guy is the floor, right? This is, once you've done the Z, you then just focus on what does the X's and the Y's look like when whatever this solid is hits the ground. Well, it's Y equals X squared. And you notice I'm doing the whole happy face and not just the typical right-hand side, because nowhere in question 12 did it mention first octant. Nowhere in question 12 did it say it was bounded by the planes. So since there's no restrictions, I'm doing that guy. And that's good, except I've ran out of information. Don't I need a Y? I need to know, do I stop here? Do I stop up here? Do I stop here? Do I, does it go at an angle? I need something else, don't I, for the Y's? And I'm going to return to this guy. When you hit the floor, won't Z be 0? Right? When you hit the XY plane, Z will be 0. And doesn't that tell me that Y equals 1? So what I've got here is that. Are you happy about how I found the Y equals 1, the missing piece of the picture, right? Because a shape has to be enclosed. You can't just have a happy face going on forever, because if you did, I guess Y would be infinity, right? And that's not a good idea. Take the equation that's got a Z in it, make Z equals 0, and you'll very often find that hidden inside that information is something to do with the X or the Y, in this case, the Y's. And I'm on a roll here, so I am going to go vertical again. And if you do a little bit of work, can you trust me that these two guys are 1 to negative 1? So I now know X's. And what about the Y's? Oh, that's a little bit trickier. This rectangle, would you agree that the lower of the rectangle is at Y equals X squared, and the top of the rectangle is at Y equals 1, right? Y equals X squared at the bottom, Y equals 1 at the top. Y equals X squared at the bottom, Y equals 1 at the top. Are we good? Right, I have the limits of X's, the limits of Y's, and the limits of Z's. So since it's a volume question, I'll just do X goes negative 1 to X equals 1. Y equals X squared on the bottom to Y equals 1 on the top. Z equals 0 on the bottom to Z equals 1 minus Y. And 1 dz dy dx. Now, that guy there is guaranteed. He's got numbers. Why is that the right order? And if I switched them, I would have problems. Why should this happen before that happens? Okay, think it through. If I do this one first, isn't my answer going to have Y's in it? And isn't Y's going to play well with the next fella, right? If I switch places with it, isn't this answer going to have X's in it? And isn't this answer going to have Y's in it, but the Y's have disappeared, right? There's no more DYs. If I switch the order in that, can you trust me that when you're finished, your answer will not be a number, it will be an expression with a variable in it, probably a Y or a Y squared in it. And that's why that's a bad order. Right. So if you have two and you're not sure who's first and who's second, because they both look equally ugly, try and think of what order would make the variables disappear. If you get it wrong, don't you just go back and switch the order and that'll fix it, right? So it's not the end of the world, it just means you did more work. Right, same question. Do you want me to continue with this one, or is this good enough? Jeanette, you've not said anything. Do you want me to continue with this, or is this good enough for you?
That's good enough for me.
Not good? Okay. And by the way, if you do it right, the answer is 8:15. So if you do it as practice, you can check yourself. So, wow. Can you remember doing those questions with centre mass? But we did it with double integrals, and that would allow us to find the centre mass of a two-dimensional object. Well, guess what? We're now going to find the centre of mass and the mass of a three-dimensional solid. The density function, oh, I haven't done the density function for this fella. Oh, here it is, there. The region, the solid shape is a cube. X goes from 0 to A, Y goes from 0 to A, Z goes from 0 to A. You don't need this for the question, but I'm going to draw it anyway. There's A, so you imagine it goes something like this, and then it goes up A, it goes up A, and it goes up A, and then it goes like that. Okay, can you visualize a cube, right? And the values of the cube are A, so A is just a fixed number. Now, the density function, forget about this stuff, we'll talk about that in a minute, is that at any given point in that cube, if you want to call it the weight of the object, its density, is given by whatever the value of 2x squared plus 2y squared plus 2z squared is. And now I'm going to make an assumption to make my life easy. I am going to use symmetry. Would you agree that that cube is symmetrical in x, y, and z? But that's not enough. Isn't the density function also symmetrical in x, y, z? Now, the assumption I'm going to make then is that the centre of mass, all three will be the same. So I want to save myself a lot of work. If I notice that there's some symmetry going on, can't I just find x bar? And if it's a half or a half A, then y bar is a half A and z bar is a half A. And I can get away with that because the density function is symmetric and the 3D object is also symmetric. If this was x squared plus 2y squared plus 3z squares, all bets are off. You'd have to find all three. Now, over here, is the formula for calculating x bar, y bar, and z bar. It's 1 over m, the triple integral, x times the density function. Y bar is very similar, right? 1 over m, the triple integral of y times the density function, and z bar, 1 over m, the triple integral of z times the density function. And m is the mass of the object, which you will find by finding the triple integral of just the density function. So these questions are massively big because of all the things you do. But the good news is, since x bar is the same number as y bar is the same number as z bar, can't I get away with only needing to find one of them and then duplicating the other two? So that's something. So let's begin by finding the mass of this object. It's going to be from x equals a, oh sorry, x equals 0 to x equals a, that's better. From y equals 0 to y equals a, and from z equals 0 to z equals a, and the density function is 2x squared plus 2y squared plus 2z squared. And in my situation, it's dz, dy, dx. Now I'm going to cheat and save some time here. Can you trust me? That's an A, by the way. That if you find this triple integral of this function, the mass ends up being equal to that guy. Well, you just take that as granted. You can check it yourself later. But it's a fair amount of work, so I don't want to do it. Okay. If you don't like that, do you want me to do one piece of that integral just to show you the process, or can you imagine plugging in the guys yourself? Your choice. Do you want to see a little bit about it, or are you willing to accept that that's the final answer when you're done? I'm open to, oh, I got a choice. Let's find out. You're voting for the class. You're good. We are moving on now. So I now know that the mass of that cube is whatever 2a to the 5 is. And it doesn't matter if I get x bar, y bar, or z bar. Can you trust me? You end up getting the same thing. So we don't need to worry about that. So just because I like, I'm going to do x bar. It's 1 over the mass, which is this guy. The same triple integral as before, right? So that's going to be 0 to a, 0 to a, 0 to a. The difference is it's going to be x times the density function. Then we'll do a dz, a dy, and a dx. So that ends up being 1 over 2a to the 5. This guy here is x equals 0 to a. This guy is y equals 0 to a. And this guy is z equals 0 to a. And it's x times this ugly guy. So 2x squared plus 2y squared plus 2z squared dz, dy, dx. So x bar is this guy, finally this guy. 2x cubed, 2y squared x, and 2x z squared. Integrate with z, integrate with y, and integrate with x. And if you do all of that, the answer you get will be like whatever it is, 15 minutes later anyway, the answer will be 7/12 a. So can you imagine all of this is going to be a to the 4 and maybe 7/24 a to the 4, and that's what you get when you tidy it up. Are you comfortable with just assuming that this horrible integral eventually does become that guy? Or would you like to see me do it? Anybody got a preference? No. Okay. So the center of mass, which is x bar, y bar, z bar, because of the symmetry I spoke about earlier, which says that in this one situation, they're all going to be the same thing. There's your equation for your center of mass. Are we good? Okay. and definitely shifting along here. I think since this is the last one, I should really do it all the way to the end. It's find the mass and the center of mass of this solid. And the solid is given by all of this information, right? This fella here, that guy, this is your density function, and we're good to go. Now, you can see the answer here, right? Has the x's and the y's are equal to each other. Okay. Now, the reason why that happened was, do you notice that the density function is not symmetric? But the density function doesn't have x in it and doesn't have z in it. And that's a good indication that these two guys are going to be the same thing, because if they don't have an x or a z, it's not going to affect their answer. So, this guy, I'm going to start here. If I rearrange this fella to get z, I get this guy. And if I use that piece of information, I get this guy. So I've already got my limits of integration for z. I now imagine this shape, right, being on the xy plane. And all I really know about it right now is that x is 0, which is the y-axis, and that y is 0, which is the x-axis. And that's about it. Well, we've done this a couple of times now. This piece of information here, right, this guy here, or you can write that guy there. If you take this fella here, and you want to know what does that thing look like when it hits the floor, which is the xy plane, you make z equals 0. And that's the straight line that goes from here to here. So do you see how I found the triangle? It was hidden in this guy, right? When you don't know what the floor looks like, make z equals 0 and it'll tell you a little bit about what's going on. In this particular triangle, which is a pretty common shape, the x's are going to go from 0 to 4. 0 to 4. So that's, we got this guy. And the y's are going to go from the bottom of this rectangle to whatever the top is. The bottom is 0. What about the top? How am I going to find out what goes where my finger is here? What will we do? What will we do? Any takers?
Rise over run, so -1.
Okay. And then it adds 4. If you do enough of these, do they start becoming same old, same old? Yeah, I've done 5 triangles. I think I know how to do, you know, the limits of integration for a triangle, right? Hopefully, in this case, x's first seem to work a lot. Probably a lot of the time that's going to be the case. Sometimes don't you have to go horizontal because of other reasons, right? And if you go horizontal, it's y equals 0 to 4, and then you have to rearrange the equation of the line to get that. But those 3 actually work well this time. So I now know that x goes from 0 to 4. Y goes from 0 to -x, add 4. And z goes from 0 to 4 minus x minus y. I think in this case, it's pretty obvious, ugly, less ugly numbers. The density function is this guy. We're going to do a dz, a dy, and a dx. Let's do a dz. If you integrate 3y with respect to z, you get 3yz. Evaluated from z equals 0 to z equals that guy. If you plug z in here, you get 3y times this guy, minus 0, so don't care about it. Multiply it out, I get 12y, take away 3xy, take away 3y squared. That guy. Pause for a minute, give you a chance to catch up. I don't think this is difficult, it's just laborious, isn't it? It's just pretty much power rules of various kinds going on. I'll now do that one. Well, if you integrate these three guys with respect to y, there's a lot going on. This guy becomes 6y squared. This guy becomes negative 3 over 2 x y squared. And this guy, oh, that's at least something, is y cubed. And you're going to evaluate from y equals 0 to y equals negative x, add 4. We'll do that. You're going to get 6 lots of negative x, add 4 squared. Take away 3 upon 2 x, negative x, add 4 squared. Take away negative x, add 4 cubed dx. Okay, well, I've committed, so I'm going to have to do it. That's going to get me, that squared is him, minus 8x plus 16. That's that one done. This is going to be 3 upon 2, the same stuff. And this guy is going to be God in Himmel. That guy's going to get you, well, let me do a little shortcut. It's going to be a 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay. So I'm going to get negative x cubed. Then 3 lots of that guy squared times that. So I'm going to get 12 x squareds. Then I'm going to get 3 lots of that guy and that guy squared, which is 16. So I'm going to minus 48x. And I'm taking that guy and cubing, and I'm going to get 16. And if you're wondering what the heck this is, it's called Pascal's triangle, and it's a way of a relatively quick way of foiling multiple powers like x something cubed, x plus 2 squared, x plus 2 to the 10. So here we go. I'm going to have 6x squared, take away 40x plus 96. This one is negative 3 upon 2x squared plus 12. Oops, there's an x there. So plus 12x. And there's an x there as well. And this guy at the end is negative 24. And this one is 2 negatives, so that's an x cubed. Take away that guy, so take away, so it's take away 12 squared. Take away, that means it's add. And finally, 16 dx. Okay, I'm going to have an x cubed. That's going to get me -6, which is going to be doubled up to 12, so it's -15 halves x squared. That guy is going to be 12x. And this guy is going to be a pain in the butt. That's what this guy's going to be. That's going to be 72, 82, 88. Okay, I guess there comes in a point in time where you have to kind of bite the bullet. Can you just trust me that if I integrated this last guy, I would end up with 32? It's amazing that it would be, but if I did everything correct, that's 32. What I'm not going to do now that I've kind of fought my way through that one is I'm going to get X bar or Y bar or Z bar. But since there's only one of these buggers, the pattern is going to be, because yours will be different numbers, this guy and this guy here are going to be the same thing. And that guy in the middle is whatever it is. So at least if I get X bar, I get that one for free, but I'm still going to have to do Y bar on my own. The only difference between all this horrible mess that I've just done is that we would have 1 over 32. Let's find my formula again. Where is it? No, it's gone. Okay, you would have 1 over the mass, the same triple integral, but x times, right, all the stuff that we would have to do. So you'd have to do that guy. And since the fella that we're dealing with is 3y, it would be the triple, it'd be 1 over 32, the triple integral of 3xy dv. So it looked very similar, but you see there's an extra term now in x. I'm not going to ask you, do you want me to continue with this one? Because I think my brain would explode if I had to do it based on how ugly the thing ended up. I hope that's 32. If it's not, it's just because I screwed up with a sign somewhere and there's a lot in it. Now, how would I do it? Let's talk a little bit about the test that's coming and what you can do. How would you get a question like this in a midterm? Well, it'd be very likely to be impossible in the time you've got, because if you had to do everything that I've skipped, right, wouldn't this question be at least a half hour on its own? And that means that, you know, I'd be lucky to get 5 questions in the midterm. What I could simply do is I can do various things. I could just ask you to find that guy, 32. I could tell you that that guy was 32 and just ask you to find one of the 3 pieces, maybe X bar, maybe Y bar, maybe Z bar. And by doing that, at least you're showing me that you know the process, but you don't want to spend 40 minutes doing one question. So far, so good. Now, you are going to be allowed in the midterm the standard integral formula. You're going to be allowed in the midterm anything that you can write down, like formulas, although to be honest, there's not that many. There's a formula here for the center of mass, but if I gave you that question, I'd probably put it in the test anyway, so you wouldn't need to remember it. There's not that many formula out there. Does anybody remember that guy? Yeah. That's one of the few formula that we actually have. Isn't this the formula that you would use to decide if it's a local max, a local min, or a saddle point? Remember max and min stuff? That's what that guy is. So if you don't know that formula, you may want to write it down as one of the formulas that you've got. I don't know if I would call this a formula. I think it's more of a process. When I write that guy down, what do you see? When would I start using that guy? Oops, that's not a good answer. When did this get used? Okay, I'll not tell you. I'll let you find out. Because if I end up giving you a question about it, it would be helpful if you knew what to do. So go find out what that guy is. I think he happened around about week 2. And there's a French sounding name attached to the guy. Okay, that's pretty much all I want. So I'll hang about for any questions. It's a short day today. Remember what I said, Friday, anything you need, anything you want to go over, just drop in. I'll try and help you. Obviously, I'll help you as soon as those who don't need to be here have left. And that's about it. Bye-bye, guys, unless you hang around.